Hi friends, welcome to my channel. So today we will check a graphical method. So how we are going to solve graphical method. So we all know that in linear programming problem there are different solutions. One is graphical method, we have simplex method, we have transportation problem, and also assignment problem. So these are the major things in the linear programming problem. So we'll check one by one. So let us start with the graphical method. We'll take one example. So here is the example. Maximum of z is equal to 2x1 plus 8x2, which is subject to 3x1 plus 2x2 less than or equal to 6, x1 plus 4x2 less than or equal to 8, and x1 and x2 greater than or equal to 0. So we all know that first is the objective function, second two are the constraints, and third one is a non-negativity condition. So first in the solution what we are going to do is we are going to solve this. So by making the equations. So inequalities what we have, so those inequalities will be made to equations, that is 3x1 plus 2x2 is equal to 6 and x1 plus 4x2 is equal to 8. By solving these two equations we are going to get the coordinates for the graphical method. And in the graphical method the most important thing is we are going to get the coordinates. If we don't have the coordinates we cannot plot a graph on, right? So let us solve equation 1. Let us assume x1 is equal to 0. So put x1 is equal to 0 in first equation. So that first equation 2x2 is equal to 6, x2 is equal to 3. So we have coordinates 0, 3. Similarly, put x2 is equal to 0. So in this case what happened? 3x1 is equal to 6, x1 is equal to 2. So coordinates are 0, 2. So now we have coordinates from the first equation 0, 3 and 2, 0. So let us say that for the second equation also find it in a similar way. So what is the second equation? So second equation is x1 plus 4x2 is equal to 8. So x1 plus 4x2 which is equal to 8. Put x1 is equal to 0, then you will get the value for x2, that is 2. Put x2 is equal to 0, then x1 will become 8 by solving these equations. So this is one way of understanding of the equations. So we are solving these equations, and when we are solving these equations we are getting the coordinates x1 and x2. So for both the equations we will get the coordinates x1 and x2. So those coordinates will be plotted on the graph, so that when we plot these coordinates on the graph we will get the solution. So from equation 1 we have coordinates, from equation 2 also we have coordinates. So from equation 1 0, 3, 2, 0, from equation 2 we have 0, 2 and 8, 0. So this is one of the understanding. So let us construct the graph by using these two coordinates. So graph, we are going to construct a graph. A graph generally have the horizontal line and as well as vertical line. So what comes in the horizontal line and what comes in the vertical line? For example, in the horizontal we will write all x1, in the vertical space we will write x2. So x1 coordinates and x2. So x1 x2 is 0, 0. Then x1 we will write 1, 2, 3, 4, 5, 6, 7, 8. x2 we will write 1, 2, 3, 4, 5, 6 up to like that, so that we are going to easily plot these values on the graph. So plotting these values on the graph easily. So first equation is what? First equation is we have 0, 3 and 2, 0. So these things first let us plot. so that the next equation can also be plotted on the graph. So whenever you solve the graph, you can have a graph paper. You can take the graph paper so that it is easy to identify the coordinates on the x-axis as well as y-axis. So x1 is considered as a x-axis and x2 is considered as a y-axis. So x1 and x2 we have. So that means x-axis and y-axis, the coordinates for both that we have. So we place in the graph. So first equation is 0 and 3. So 0 is on the x-axis side, 3 is on the y-axis side. So put it on that and you will get the equation. Similarly for the second equation 0, 2 and 8, 0. So 0 on the x side, 2 on the y side, and 8, 0 means 8 on the x side and 0 on the y side. So like this. So when we plot these graphs, we are going to get the solution. So what is the solution for the graph? That is the space below the common area. So what is the common area for this graph is, that is O, A, B, C. So this is the common area that I am making it into the graph. Like I am rubbing this with the colors. So common area is can be a solution for the graphical method. Since it is a less than or equal to type, the common area, that is intersection point. So below the intersection point, the common area, that in case of less than or equal to type. If it is a greater than or equal to type, it is outside of the intersection area. So the common area is identified here. Then the solution is O, A, B, C. O we can take 0, 0. A we can take, B we can take, and C we can take. O is x-axis and y-axis 0, 0. A is like 2, 0. Then we have B is, there is no coordinates there because B is the intersection of equation 1 and equation 2. So therefore we require to solve equation 1 and equation 2 in order to get B. So solve B, that is solve equation 1 as well as equation 2. So put equation together. So when we put these equations together, it is easy to solve the equation 1 as well as equation 2. So solve these two equations and get the values for B, that is 0, that is, so solve the equations 2, then we can get values for the x1 as well as x2. So let us say 3x1 plus x2. 3x1 plus 2x2 is equal to 6. x1 plus 4x2 is equal to, x1 plus 4x2 is equal to 8. So here we are solving two equations. 3x1 plus 2x2 is equal to 6. x1 plus 4x2 is equal to 8. So multiply equation 2 with 3. So just eliminate 3. So when we eliminate 3, the remaining is 12x2. So 12x2 minus 2x2, that is 10x2. So 10x2, which is equal to 24 minus 6, that is 18. So here x2 is equal to 1.8. Substitute x2. So when we substitute x2 in any of the equation, so if you substitute x2 in any of the equation, you will get x1 as 0.8. So you have x1 and you have x2. So both these comes under B. So now we have O, we have A, we have B, as well as we have C. So now O is 0, 0. Then B is 1.8, 0.8. That is x1 is 0.8, x2 is 1.8. So 0, A, B, and C. So write all the values here, and all these values, after this, substitute these values into objective function. When you substitute these values in the objective function, since it is a maximization case, highest value is the solution. If it is the minimization case, lowest value will be the solution. So what is the difference between the highest and lowest value means? Maximization comes under sales maximization, profit maximization, resource utilization, profit revenue maximization. So these things. Minimization comes under cost cutting, resource mobilization, reduction of the resources. So this comes under the minimization. So in minimization object function, if it is optimum is minimum, optimization objective is minimizing the cost, then low value is the answer for the minimization. But if the objective is maximization case, that is optimum value is maximum value of the solution, then we have to select the maximum value for the solution. So maximum is 16 here, but here again another thing is the solution comes with the 2 points, one is B and C. So we generally assume, since the two equations we have solved, we assume the solution lies with the two equations, the value is 16. So 16 is B. Then there is also an alternative solution, that is C, because both have the similar values, 16 and 16. So this is the how we are going to solve a linear programming problem with the graphical method. So here most of the time graphical method is a step-by-step procedure. So we have to think how we are going to solve a graphical method in a step-by-step sequence. First step we did what? Converting the constraints into equations, finding the coordinates, plotting them on the graph, finding the values, substituting in the objective function, and getting the solutions. So like this we are going to find it. So if you like this video, please subscribe, share and like. So thank you all of you for watching this video. So for more videos, please subscribe to my channel and for continue watching. Thank you.